Hi everybody, this is a video to help you know how to play the multiplying fractions activity that's been included in your resources for this week. Once again, there's 3 activities there, and this is the multiplying fractions one down here. There's the rules for that. You're going to need the digit cards, which are in there, and I've already cut them out ahead of time, as you can see. You're not going to need the negative integer cards, so take the negatives out and put those to the side. You're also not going to need the zeros for this because you'll run into some problems if you have a 0 in your fraction, and of course you won't need the decimal points. So take those out and use your positive integer cards. The way this works is you are going to turn over the first card to make a numerator, turn over the second card to make a denominator. So 6/9 is my first fraction, and I'm going to multiply that by another fraction. So here we go again, numerator 2, denominator 7. So I want to do 6/9 times 2/7. I'm going to move these out of the way, and I've already done the work ahead of time just so you can see how it's done and speed the video up a little bit. But here's my 6/9 times 2/7. Remember to multiply the numerator straight across, so I get 12. Multiply 9 and 7 straight across to get 63. And then I need to simplify my answer if possible. 12 and 63 can be simplified, and this is tough for a lot of us. 12 and 63 can both be divided by 3. 12 divided by 3 is 4, and 63 divided by 3 is 21. So 4 over 21 is going to be my simplified answer. 4 and 21 don't have a common factor that they can both be divided by, and so I'm finished multiplying there once I've simplified it. Now, a little bit further explanation of that is that the reason why I knew 12 over 63 could be simplified is because I knew that 12 and 63 had a common factor of 3. So be sure to think about what common factors your numbers might have. So I listed the factors of 12, 1 times 12, 2 times 6, and 3 times 4, and I listed the factors of 63, 3 times 21, 7 times 9, and 1 times 63. And if you'll notice, 3 is the largest common factor that they both have. That's why I chose to divide by 3 up here in this step. So that let me know that I needed to simplify a little bit. Okay, well, how did I know to stop when I got to 4 over 21? Again, I listed the factors of 4, 1 times 4, 2 times 2, and here's the factors of 21, 1 times 21, 3 times 7. There are no common factors other than 1, so this numerator and this denominator don't share a common factor other than 1, so I'm going to leave it alone, and I'm finished there. You can keep playing this game, you can keep turning over cards and making different fractions and practice multiplying, but you're going to run into a couple of other issues along the way. So let's talk about one of the ones you might run into. Well, one of the things that you might run into is you might run into one of your fractions being an improper fraction where the numerator is larger than the denominator, or you might even end up where both of them are that way. So for example, if I was playing, we got 4/5, turn over some more cards, 4/5 times 8 over 2. All right, so now I've got an improper fraction. So there it is, I've written it down, and everything works the same way. I'm going to multiply straight across. 4 times 8 is 32, 5 times 2 is 10, but again, I may need to simplify. There's a lot of ways that you could do this. There's a lot of different strategies, and I'm going to talk to you about all of them, I think. So 32 over 10, which is our unsimplified answer, can also be written as 3 2/10, and that's because all fractions are division problems. So 32 divided by 10, that means 10 is going to go into 32 3 times. 3 times 10 is 30. 30 is 2 away from 32, so you have 2 left over, and it was out of 10 to start with, and so it's out of 10 again here as we rewrite that as a fraction. This can simplify to 3 1/5 because 2 and 10 have a common factor of 2. So 2 divided by 2 is 1, and 10 divided by 2 is 5. So that's kind of a fast way to do it, maybe mentally. If you're really good at converting improper fractions, you may be able to do that quickly in your head. Another way to think about it is as the division problem. So I just rewrote this as 32 divided by 10 with long division. So 10 goes into 32 3 times. There's my 3. 3 times 10 is 30. 32 minus 30 is 2. And so now I've got my 3 and my 2 tenths. So there's my 3 and 2 tenths, and here's my 3 and 2 tenths. So there's a way to see it with long division, okay? You could also do it this way. You could simplify the fraction before you divide it. So maybe you notice that 32 and 10 can both be divided by 2 because they're both even numbers. So 32 divided by 2 is 16, and 10 divided by 2 is 5. That's going to be 16 fifths. Well, 16 fifths is also equal to 3 and 1/5, just like 32 over 10 was equal to 3 and 1/5. And the reason why that is true is because if we do long division with 16 divided by 5, 5 goes into 16 3 times. 3 times 5 is 15. 16 minus 15 is 1. And so now we have our 3 and 1/5, just like we have 3 and 1/5 here. So no matter how you do it, as long as you have multiplied correctly, straight across, and simplified correctly, you should end up with 3 and 1/5. So that is what might happen if you get an improper fraction, okay? Now, this game can also be played with division. It does not have to be multiplying fractions. So I'm going to show you one last piece, how you can play this doing division. So I made some more fractions using my integer cards, and I used a division symbol instead. All right, well, you got to remember, when you divide fractions, you don't really divide them. You actually multiply by the reciprocal. And that's what this little saying means that we use in my class. When dividing fractions, don't be shy. Flip the second number and multiply. What we're really meaning there is, instead of dividing, multiply by the reciprocal. The reciprocal of 2/7 is 7 over 2. So from there, we multiply straight across. 6 times 7 is 42. 9 times 2 is 18. Now we're back to where we need to simplify. So I'm going to try and simplify this. I notice right away that 42 and 18 are both even numbers. So what that means is they can be divided by 2. So 42 divided by 2 is 21. 18 divided by 2 is 9. I also noticed pretty quickly that 21 and 9 can both be divided by 3 because they share that common factor of 3. Remember, if you don't know what factors they have, you can always go back and make yourself one of these lists for your numerator and denominator to figure out what factors they have. I just knew that these were both divisible by 3. So 21 divided by 3 is 7. 9 divided by 3 is 3. And 7 and 3 are both prime numbers, so they are not going to share any factors other than 1. And so now I'm ready to convert that to a mixed number or a mixed fraction because we don't want to leave it as an improper fraction. So 3 goes into 7 2 times. 2 times 3 is 6. 6 and 7, the difference between them is 1, and it was over 3 to begin with, so it's still over 3 here. And then there's the division again to show you one more time how I got 2 and 1/3. Okay, so you can divide fractions with these integer cards. You can multiply fractions if one of them is improper or if both of them is improper. And of course, you can also multiply fractions that are proper fractions. I hope this helps you. I want you to play this game and just generate lots of different fractions and practice multiplying them. And this will help keep your skills up. And as we move forward into the coming weeks, it'll help you be able to do some of the other things that we're going to do. Thanks for watching.